Welcome to the channel Complete Data. So in this lecture we discuss the resultant calculation of the two concurrent force, and in the previous class we solved one question regarding the resultant force of two force, what is 100 Newton and 150 Newton, and the angle between them is 45 degree, and this is concurrent, and we have to find the resultant. And next example, which is find the magnitude of two forces such that they act at right angle. That means angle will be 90 degree, and the resultant is root over of 10 Newton. Okay, uh, but if they act 60 degree, then resultant will be at root over 13 Newton. Okay, so we have to find the two forces, that is F1 and F2. Okay, so we know the resultant force formula will be R is equal to root over of first force F1 square plus F2 square plus 2 F1 F2 cos theta. Okay, so putting the value for the first resultant is root over of 10 Newton. That means root 10 is equal to F1 square plus F2 square whole root over, as theta is 90 degree, so cos 90 will be 0. Okay, so squaring both sides we get 10 is equal to F1 square plus F2 square. This is equation 1. Okay, next similarly, given another angle will be 60 degree when the resultant is root over 13 Newton. Okay, so putting the value, resultant will be root over 13 is equal to F1 square plus F2 square plus 2 F1 F2 cos 60. So upon solving, cos 60 value is equal to 1 by 2, that is 0.5. so squaring both side, it will be 13 is equal to F1 square plus F2 square plus 2 F1 F2 1 by 2. F1 by 2 1 by 2 will cancel. Okay, so it will be F1 square plus F2 square. From equation 1 we get F1 square plus F2 square is equal to 10, and 30 minus 10 is equal to 3, which is equal to F1 F2. So this is equation 2. Okay, we know F1 square plus F2 square, that means A plus B, this is related to A plus B whole square, which is equal to A square plus B square plus 2AB. Okay, so F1 plus F2 square is equal to F1 square plus F2 square plus 2 F1 F2. From equation 1 we get F1 square plus F2 square is equal to 10, and F1 F2 we get from equation 2 is equal to 3. That means 2 into 3 is equal to 6. So net will equal to 10 plus 6 is equal to 16. Okay, so F1 plus F2 square is equal to 16. That means F1 plus F2 is equal to root over of 16, which is equal to 4. Okay, this is equation 3. Okay, similarly, F1 minus F2 square is equal to F1 square plus F2 square minus 2 F1 F2. Okay, F1 plus F2, that means F1 square plus F2 square is equal to 10. From equation 1 we get. Okay, and 2 into F1 F2, F1 F2 is equal to 3, 2 into 3 is equal to 6, so 10 minus 6 is equal to 4. So by root over it will get F1 minus F2 is equal to root over 4, which is equal to 2. This is equation 4. From equation 3 and 4 we get, given F1 plus F2 is equal to 4 and F1 minus F2 is equal to 2. So adding we get F1 plus F2 minus F2 cancel, so 2 F1 is equal to 6, implies that F1 is equal to 6 by 2 is equal to 3. Okay, so by putting F1 is equal to 3 we get F2 is equal to 1. Okay, so F1 is equal to 3 Newton and F2 is equal to 1 Newton. So very important formula is equal to find the resultant between the two forces which is concurrent. We use formula, this formula is equal to, very useful. Okay, R is equal to F1 plus F1 square plus F2 square plus 2 F1 F2 cos theta and whole root over. Okay, next we have to differentiate between component and result part. So very important point is when a force is resolved into two parts along two mutually perpendicular direction, that means generally we take it in 2D, which is this is x direction and this is y direction, and we have to resolve these many forces in according to x direction and y direction. And how to resolve many forces in x and y direction we will see in the uh, latter part. Okay, so when a force is resolved into two parts along two mutual perpendicular directions, the part along those direction is called resolved part. Okay, but when a force is split into two parts along the two assigned direction not right angle to each other, those parts are called component of the forces. So if we have to resolve into two mutually perpendicular direction, it is called resolve part. And if we have to resolve in any direction but is not a perpendicular, then it is called as component of the force. Okay, so all resolve parts are component, but all components are not resolve part. Okay. Next, a resolve part of force in a given direction represent the whole effect of the force in that direction, but the component of the force direction does not represent the whole effect of the force in direction, as they are not perpendicular, that means x and y direction, so it is not representing the whole effect. Okay. Next, the algebraic sum of the resolve part of the two concurrent force along any direction is equal to the resolve part of the resultant along the same direction. Okay, this is very important. Okay. Next, analytic method of determining the resultant of any number of coplanar concurrent forces. So these are the forces P, Q, and R and T, and we have to resolve this in x direction and y direction. Okay. So how to resolve in x and y direction which are mutually perpendicular to each other. Okay, and the forces P, which is at angle alpha with respect to x-axis, and we have to measure this angle with respect to x-axis. Okay, and Q, which is angle will be beta, and R will be theta, and T will be gamma. So so we have to resolve the forces in x direction. That means summation of forces in x direction will be, this is P and this is alpha. So this component P component with respect to x axis will be P cos alpha, and Q component in x direction will be plus Q cos beta, and R component will be, this will be cos theta, and T will be cos gamma. Okay, and similarly we can resolve in y direction, which is equal to P sin alpha plus Q sin beta plus R sin theta plus T sin gamma. Okay, already cos replaces sin in y direction as theta is with measuring with respect to x-axis. Okay, these are the component how to resolve in x and y direction. Sorry, this will be resolve part as they are the mutually perpendicular direction. Okay, mutually perpendicular direction we have to resolve, then this part will be resolve part, and if it will not perpendicular direction, then it is called component. Okay, so all components or resolve part are component, but all component are not resolve part. It is very important, you have to remember. Okay, star mark. Okay, next, all the forces resolve in x and y direction. Next, these four forces are resolved into two directions, that means x and y. Next, we have to find the resultant later on. So resultant will be summation of forces x direction square plus summation and y square plus 2 into x and y cos theta, as theta is 90, so cos theta is 90, cos 90 will be 0, so no need to write, only summation of x square plus summation y square and whole root of give you resultant of this result part, this 4 process. Okay, p q r a t. Okay, this will be resultants. Next, so the resultant will be how much angle with respect to y-axis is equal to, so tan theta is equal to summation of y is divided by summation of x, and theta will be the how much resultant is angle by from x-axis. So when summation of x-axis is positive, r will lie either between 0 to 90 degree. Okay, and this things will be solved when we solve a problem. Okay, very much understand when we solve a problem. Okay, so let's see the example. A particle acted on by 3 forces. One force is 2 Newton, and next force is 2 root 2 Newton, and third force is 1 kilonewton. Okay, so given data is f1 is equal to f2 is equal to 2 root 2, and f3 is equal to 1 kilonewton. Okay, next part is the first forces is horizontal and towards the right, and second acted at 45 degree to horizontal, and next incline to upward right, and third is vertical. So calculate the resultant of the given process. So we know the resultant will be summation of x square plus summation y square and root over. Okay, so we have to find the summation of x, and summation of x is equal to first process is 2 into cos and angle will be, it is first process is horizontal, so horizontal will be angle with respect to x will be, this is x axis, this is y axis, this is horizontal, so this forces 2 Newton is angle 0 with respect to x. Understand? Okay, so it will be 2 cos 0, and second will be 45 to horizontal, second is, this is 2 root 2, this angle is 45, so 2 root 2 with respect to x axis component will be 2 root 2 cos 45. Okay, next is vertical, so it, magnitude is 1 kilometer, 1 Newton is 90 degree, so 1 cos 90, so cos 90 is equal to 0, so this part is neglected, and cos 0 is equal to 1, so this is 2, and 2 root 2 cos 45 is 1 by root 2, so 1 by root 2 and 2 root 2, 2 root 2 cancel, so 2 2 equal to 4 Newton. Okay, this is equation 1. So resultant forces in x direction, sorry, the result part of these 3 forces in x direction will equal to 4 kilonewton. Next we have to calculate in y direction, all will be same, and cos and sine will be replaced by cos. Okay, so summation of y is equal to 2 sine 0, 2 root 2 sine 45, 1 sine 90, so sine 0 is equal to 0 and sine 90 is equal to 1. Okay, so 0 and 2 root 2 sine 45, 1 root 2, 2 root 2 cancel, 2 plus sine 91, 1 into 1, 2 plus 1, 3 Newton. This is equal to 2. So putting, we get r is equal to summation x square plus summation y square. Summation x is given from equation 1 is 4, 4 square plus 3 square, and root over is equal to 5 Newton. Okay, this is the resultant value for kilonewton, and sorry, this is 5 kilonewton, sorry, 5 kilonewton. Okay, next we have to find the angle how from x-axis the resultant is acted. Okay, this is tan theta is equal to summation of y divided by summation x is equal to 3 by 4 is equal to 0 0.75. That means theta is equal to tan inverse 0 0.75 is equal to 36.9 degree from x-axis. So we have to draw from x-axis 36, that is theta is equal to 36.9 degree, and the magnitude will be 5 kilonewton, the resultant of the three forces, which is 2 root 2, 1 and 2 kilonewton. Okay, so unit are kilonewton, sorry. Okay. Understand? Next, next example, to resolve the given force into two perpendicular coordinate. Okay, this is 15 newton. We have to resolve into x and y direction. So it will be in x axis is equal to 50 cos 30, and it will be 50 sin 30. So 50 cos 30. So 50 into cos 30 value is equal to 0.866, which is equal to 43.3 newton, and this is sin 30, that means 1 by 2, which is equal to 45 newton. Okay, this is simple. This is resolved into one process into two component in x and y direction. Okay, okay. Here are the many problems we to solve. Okay, okay, and that's all for today. In the next class, we solve the example 1.5, which is a triangle based question. Okay, till now, bye, thank you.